everybody, and welcome back to the channel. Today I'm going to tell you how I interfaced this VOR indicator. This is a VOR and glide slope indicator, and it comes from actually a simulator itself, a very old ATC simulator from the early 80s, I believe. And I also believe that this is an original VOR and glide slope indicator from that time, and that has been modified actually with this cable. Instead of having the usual big pin rows in the back. It's going to be interesting to see this interface, not really for the needles and the flags, because this is, you're going to see, is very easy. We just use PWM, but especially for the OBS knob here, which is the one used to select the VOR course. And it's very interesting to see how this can be done, because as you know, this is a 360, this must rotate 360 or more. I mean, it has to have it needs to have a 360 rotation, 360 degree rotation, sorry. And this can't be done with a potentiometer nor with an encoder. So now we're going to see how it works, and we're going to see also the two small PCBs board, two small boards I use to interface them. This one is the one you can find everywhere. It's just an H bridge. In particular, this one uses an MX1616. This you can find very easily everywhere in on AliExpress or Amazon. And this is going to be used for the needles and the flags, in particular the to and from flag. And however, for the OBS part, which is the most interesting one, I designed a custom PCB. We're going to see all the details about that later. This one is going to be able to get the signals from the OBS and transform it into digital signals that then can be interpreted by the microcontroller, and then the microcontroller is going to make the necessary calculations to get the precise angle. So we have the two needles here and the flag off from to, and the off on flag, and also the OBS compass here, which can be rotated using the OBS knob. So for the two needles there is nothing in particular to say. We have two pins, and we can connect here plus or minus plus, and according to the polarity we give, we can have a movement towards the right or towards the left. Same thing for the glide slope needle. This one here, we have two pins, which can be again plus minus or minus plus, and in this case we're going to have a upper or lower movement. In order to interface this, I used simple Arduino PWM signal generation, but it was a bit particular because, as you can see here, we need to have polarity inversion, so plus minus or minus plus, and in order to do that, I thought I can use an H bridge. So what I did, I used a simple H bridge for a DC motor that you can find anywhere on the internet. The same thing I did for the two from flag. It has two pins, and once again they can be plus minus, and we have the from, or minus plus, and we have the to. So I decided to use PWM once again, and to have also this transition, smooth transition from to off, and from off to from. And I used once again an H bridge. For the off on flag, we have already, again, sorry, another 2 pins. So in this case, I used plus 5 volts or 0 volt coming from Arduino output pin. What is more interesting to check how it works, in my opinion, is the OBS compass here. Actually, the first time I saw it and I started measuring things, I was not really able to understand what was going on. I actually measured something like this. So we have basically I measure four resistors. I don't remember by heart what is the resistor value, but anyway, we're going to see that in more details in a moment. And the circuit was kind of like this. So all these 4 resistors connected like this, and 4 outputs, plus a 5th output, which is in the middle. Once I started measuring things, I realized that these are actually rheostats. And so when we turn the OBS knob, each of these resistor will display a different resistance according to the OBS position. And these resistors are 90 degrees apart here inside this compass. And so we're going to measure 4 different values each time at each position of the OBS knob. And thanks to these 4 values here, we're going to be able to reconstruct the sinus and cosinus components of the OBS. With a little bit of math, then it will be easy to reconstruct the angle, and so it will be quite straightforward after having a sinus and cosinus to get the angle out of it. This is a very clever implementation, and which doesn't need a synchro or a resolver to get this 360 degrees position. And I discovered that it's used in several VOR2 indicators like this, so it's not something special for the sim. It's actually used in real avionics. So I was lucky enough to find on the internet this web page, which is very nice. It's a bit old, I think, but it's quite nice to check. And it's about an F-16 simulator, and the guy came up with the same VOR2 indicator, and it was quite nice to check what he did with this. And you can see the exact same pinout that I gave to you. We have the potentiometer, kind of rheostat, I would say, rheostats, 90 degrees apart, and then the center wiper arm. He also writes details about the flags and everything. It's quite the same like the VOR2 indicator I have. And in this page, he also measured, according to the position of the OBS, the resistor values. So as you can see, for every rheostat, we measure a different resistance. And thanks to these 4 different values, we are going to able once again to reconstruct the sinus and cosinus component, and from this we're going to be able to get the angle. We're going to see this when I will show you the code that I implemented in the firmware. So once I understood this, I thought that instead of using measuring resistor, of course, we're going to measure voltages. And I also found here a very nice interface that also on this page has been published, that this guy made. And here you can see the 4 potentiometer outputs And of course, once we have a rheostat, which is not a real potentiometer, we need another resistor to create a real voltage drop and measure the voltage here at the middle of the voltage divider. And as you can see here, this is done here at this point. So we have precision 2.7 kilo ohms resistors, which are 1%. They must be precise because, of course, we're going to measure these voltages that are going to give us the sinus and cosinus components. So this must be quite precise. And basically the circuit is repeated, the same circuit that you see here is repeated 4 times. You see here, so we read the voltage here, and then this voltage gets to amplifier here. I was thinking of using this plus 12 minus 12, but I realized I don't need it, because what I need in my case is just from 0, something which is able to give me from 0 to 5 volts. So I was able to implement this with just positive voltages. In my case, so you see here that the guy uses some kind of amplification. But in my cases, I just understood that I don't need this resistor and this not potentiometer, this trimmer, sorry, this trimmer. I don't need this, so you're gonna see once we move to the computer that this, I made a PCB out of this which has this, but at the end I didn't use them. So once the signals come out here, I wanted to read them, and for reading the 4 of them, I thought it was perfect for this job. And DS1115. Before going to the actual demonstration, let's see a bit the code. I don't post this time the routine because it's quite simple. It actually uses the ADS1115 to read the 4 OBS signals that you see here. And this is something that is used to communicate, to send data and receive data from the analog to digital converter. And basically the reading of the data happens here. It's a 15 bits data, so I need to read it twice. I read the MBS and the LBS sequentially, and the magic happens actually here. I reconstruct the sinus and cosinus using the 2 components I am reading. Why this is the component number 4 and the component number 6, it doesn't matter, is because I have in the same board I read also other analog to digital values. So it happened that this is the number 4 and this is the number 6 in the array, but it doesn't matter. So I'm reading right now to reconstruct the sinus, the OBS 1, which is the address 0, and actually the OBS 2. And for the cosine, I do the same. I read the OBS 2 and the OBS 4 in order to reconstruct the cosine. And I do the difference. After that, I do the arctangent of sinus and cosine, and I multiply by 180 and divided by pi in order to get the the angle in degrees instead of radian. And with this mod float is a function that wraps the value always from 0 to 360. We're going to see that. And I also add the plus 90 to match what the OBS indicator shows. The mod flat is this function here, is very simple. It does the f mode of 360 here and on the angle, and is gonna wrap the final the angle for it to stay in between 0 and 360. If you're interested in these functions, I can put it on the GitHub. Let me know in the comments. If you need them, I will post them. So now we can really go to the setup and show you how it works. So here we are, installed the VOR2 back to his place. This is part of General Aviation Flight Sim. I am upgrading, that's quite old Flight Sim, and upgrading the electronics. And so for the needles, I connected them to an Arduino Mega, this PCB here. And the OBS, which is, in my opinion, the most interesting part, is connected, of course, to this PCB here that I showed you before. We see here the OBS inputs and the analog to digital converter here, the plus 5 volts power supply, and this is the I2C signals coming from the analog to digital converter. As you can see, I didn't use any trimmer or resistor for the op amps because I realized I didn't need them. So the next step will be I will show you how this thing works, and we will move now to the computer, and we will operate the needles, the flags, everything to check how this thing works. So here I have the General Aviation Sim controller. It's this one I'm gonna use use to check if the sim is fine, if the hardware is fine. It has a lot of input and outputs, of course, the sim. I'm not gonna into the details, but you have input, outputs, the gauges PWM. You recognize here the VOR and the glide slope. That's what's the one which is interesting for us. And let's go and go ahead and open the port. So you see already here we have some activity. We have some other ADCs. This is actually the other 4 ADCs that were coded in another routine when I showed you the code. And this is the OBS already that has been read. This is the angle. So let's go to gauges PWM, select live send while dragging, and let's see how it works. If it works, the VOR, we push it on the right, and we have actually the movement to the right and then to the left. So it works. Then let's try the glide slope up and the glide slope down. Let's also put it back to 0. Let's also try the VOR to and from. So we have the to, we also have the from. And now let's go and check on the OBS here. So we are on 193, which is correct. 150, yes. 120. 180. It's very accurate, by the way. 24. Yes, here 240. It's very accurate. Actually, this way of doing things is very accurate. I was amazed by this 300, sorry. Then we go back to 360, so 0, 1, 10, well, whatever. 50, yeah. So that's it for today, guys. If you like the video, please like and subscribe, and let me know what you think in the comments. And if you need anything, the programs to be shared, I'm gonna share on my GitHub. See you next time. Bye bye.